Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the deep dive. Today we're diving deep into Java. Yeah, Java, that programming language with the famous tagline, write once, run anywhere. And just think about it. The apps you use, those huge systems running banks, even like the little smart card in your wallet, Java's probably in there somewhere.
It really is kind of amazing how fundamental it's become, often totally unseen. It's like the plumbing or the foundation of a building. You don't notice it, but everything depends on it.
Right.
So our mission today really is to unpack why it got that foundational status. What are the core ideas, the advantages, and why it's still so important for you to understand even now.
And we're drawing on deciphering Java, write once, run anywhere for some insights here.
That's the plan.
Okay, so let's rewind back to the beginning. Sun Microsystems, early 90s, James Gosling and his team.
Yep, that's where it started. And interestingly, the initial idea wasn't, the huge enterprise thing we see today.
No. What was it then?
They were actually aiming for something quite different. A platform-independent language for smart consumer electronics. Think interactive TVs, maybe complex remote controls, that sort of thing.
Ah, okay. Embedded systems, basically.
Exactly. But then things took a bit of a turn. 1995, it goes public, and they hit with that slogan, write once, run anywhere.
And that was a big deal.
Oh, huge. It wasn't just clever marketing. It was a genuinely different way of thinking about software.
Because back then, you wrote code for Windows, it stayed on Windows, Mac code stayed on Mac. Moving it was a nightmare, right? Often a total rewrite.
Pretty much. So Java's promise was, look, if a device has this thing called a Java Virtual Machine, a JVM, your Java code will run on it. Doesn't matter if it's Windows, Mac, Linux, whatever.
That must have been revolutionary for developers. Suddenly your potential audience is massive.
It absolutely was. That
Right.
JVM, it acts like an intermediary, a kind of abstraction layer.
How does that work exactly?
Well, you write your Java code, right? The compiler turns it into this intermediate format called bytecode. Now, bytecode isn't machine code for a specific chip. It's more like universal instructions.
Okay.
Then the JVM on your specific machine, your Windows machine, your Mac, acts like an interpreter. It takes that bytecode and translates it into the actual instructions that your specific hardware and OS understand.
Ah, so the same bytecode file runs everywhere there's a JVM?
Precisely. Write the code once, compile it once, and then it can theoretically run anywhere with a compatible JVM. That's the run anywhere magic.
Right, so it's this JVM layer that gives it independence from the actual hardware.
Exactly. And that was a massive, massive selling point. Huge reason for its rapid adoption.
Okay, so platform independence is clear. Huge benefit. But what else was pulling developers towards Java? Were there other big advantages?
Yeah, definitely. Beyond just running anywhere, stability was a big one. Java built up this reputation pretty quickly for being reliable, rock solid.
Which is crucial for those big systems you mentioned, like banks, government stuff.
Absolutely.
Yeah.
You can't have those systems failing. Java's design, its memory management, error handling, it all contributed to this sense of robustness. Maybe not the sexiest feature, but incredibly important, dependable.
Like the reliable old work truck versus the flashy sports car.
That's a good way to put it. It gets the job done consistently.
You also hear object-oriented thrown around a lot with Java. What does that mean in practice, like for someone who isn't deep into coding?
So Java is what's called a class-based, object-oriented language. Think of it like building with Lego bricks. Everything's an object, and each object type or class defines what data it holds and what it can do.
Okay.
So instead of just a long list of instructions, you structure your code around these self-contained objects, a customer object, an account object, maybe a transaction object. Each holds its own information and has its own functions.
So it's like organizing things into logical chunks.
Exactly. It makes code more modular, you can reuse these bricks, and generally easier to manage, especially as programs get really big and complex. It provides a sort of blueprint.
Makes sense. And I gather there's a huge toolbox of pre-built bricks for Java.
Oh, enormous.
Yeah.
That's the ecosystem. Java has this vast collection of frameworks and libraries. Need to build a website. There are tools for that. Connect to a database. Tools for that. Android apps. Big data processing.
There's probably a Java library or framework ready to go?
Almost certainly. Things like Spring, which is huge for building enterprise apps. Hibernate for database stuff. Apache Spark for big data. The list goes on. It means you don't have to reinvent the wheel all the time. speeds things up massively.
Right, you leverage what others have already built and tested. What about handling lots of users or tasks at once? I've heard Java's good at that.
Yeah, that's multi-threading. Java has built-in support for running multiple threads of execution concurrently. Think of it like having multiple workers handling different tasks simultaneously within the same program.
So ideal for busy websites or back-end systems processing lots of requests.
Exactly. High-performance servers that need to be responsive even under heavy load really benefit from this.
And there's also this idea of longevity, right? Backward compatibility.
Yes, and that's a really significant, though maybe less glamorous, advantage. Java has historically put a huge emphasis on backward compatibility.
Meaning old code still runs.
Often, yes. Code written years, even decades ago, can frequently run on the latest JVMs without needing major changes. For big organizations with massive investments in Java code, that stability is gold. It avoids costly rewrites.
I can see how that would be appealing for businesses. Less disruption.
Plus, the community around Java is enormous. Millions of developers worldwide, tons of forums, resources, documentation. You're rarely stuck for long if you hit a problem.
Okay, so it's this mix. Run anywhere, super stable, well-structured with OPO, huge toolkit, handles heavy loads, and it's built to last with good support. That's a powerful combination.
It really is. It explains a lot about why it became so dominant.
So let's talk about today. Where is Java actually running? We know it's widespread, but can we pinpoint some key areas?
Absolutely. Let's start with your phone, Android development. Historically, Java was the language for Android apps. Now, Kotlin is also very popular, even preferred for new stuff, but a huge amount of existing Android code is Java. Many apps you use still rely heavily on it.
So odds are the phone in your pocket is running Java code right now.
Very high odds, yes. Then think bigger. Enterprise applications.
Just serious business stuff.
Exactly. The core systems for banks, insurance companies, big retailers, managing accounts, processing transactions, inventory systems, ERP software. Java is a mainstay there, often using frameworks like Spring Boot to build these large-scale applications.
The invisible machinery keeping things running.
Pretty much. And it's not just the backend. Java's big in web applications too. Technologies like Java Servlets, JSP, and frameworks like Spring MVC power a lot of large, complex websites, especially on the enterprise side.
Okay, what about handling all the data we generate now? Big data.
Yep. Java's crucial there too. Foundational tools in the big data world. Apache Hadoop for distributed storage and processing. Apache Kafka for streaming data. Apache Spark for large-scale data analytics. They are largely written in or run on the JVM.
So it's involved in storing, moving, and analyzing massive data sets. Impressive. And the cloud, how does it fit there?
Seamlessly. Java works extremely well with all the major cloud providers, AWS, Azure, Google Cloud. Its stability, scalability, and that huge ecosystem make it a natural choice for building cloud-native apps.
Especially things like microservices.
Very much so. Breaking down big applications into smaller independent services, that's microservices. Java, particularly with frameworks like Spring Boot, is super popular for building these. And it plays nicely with container technologies like Docker and Kubernetes, which are essential for managing apps in the cloud.
Okay, cloud covered. Now, you mentioned something earlier that really caught my ear, smart cards, like credit cards.
Yeah, it sounds surprising, but it's true. There's a version called Java EE Micro Edition. It's highly optimized for devices with very limited resources.
Tiny processors, minimal memory.
Exactly. And Java ME runs on billions of smart cards, SIM cards, and phones, other embedded systems. It provides a secure, reliable platform even on that tiny scale.
Wow. From massive cloud servers down to a chip in your wallet. That's incredible range.
It really is.
Yeah.
And you even find it in scientific computing sometimes for complex simulations where maybe you need that cross-platform capability and decent performance.
Okay, so the answer to where is Java is kind of everywhere in the digital realm.
Pretty much sums it up.
But look, no technology is perfect. There must be downsides or criticisms of Java.
Oh, absolutely.
Yeah.
Fair point. One common one is verbosity.
Meaning it takes more code to do things.
Sometimes, yeah. Compared to languages like Python, Java often requires you to write more lines of code to express the same logic. More boilerplate, maybe? Can feel a bit wordy to some developers.
Or more typing involved.
Yeah.
Okay, what else?
It's also often cited as having a slightly steeper learning curve, especially if you're brand new to programming. You have to get your head around object-oriented concepts, the class structure, the static typing. It's maybe not as immediately approachable as, say, a simple scripting language.
Right, that initial hurdle might feel a bit higher. Performance. Does the JVM slow things down compared to running code directly on the metal like C++? Whoa.
There can be a slight overhead. Modern JVMs are incredibly smart. They do amazing optimizations, just-in-time compilation. Often Java performance is fantastic, sometimes even better than naive C++ for certain things because of those optimizations. But fundamentally, there's that extra layer of the JVM compared to compiling straight to native machine code. So for things that are extremely performance sensitive, like maybe low-level system programming or high-frequency trading, C++ might still have an edge.
Okay, potential small trade-off there. And what about keeping up with new language features? Has Java been a bit slow sometimes?
Historically, yes, that's been a criticism. Java valued stability and backward compatibility so highly that sometimes adopting newer syntax trends or conveniences, things you might see pop up quicker in other languages, took a bit longer.
Like lambda expressions, I remember that taking a while.
Exactly. Things like lambdas arrived in Java 8, whereas other languages had similar concepts earlier. However, it's important to say the pace has really picked up. Java now has much more frequent releases, bringing new features more incrementally.
So it's evolving faster now than it used to?
Definitely. Less conservative, perhaps, in recent years.
Okay, which brings us to the big question. It's 2025. Is Java still relevant? Is it still a smart choice?
Unequivocally, yes. Absolutely relevant. It's consistently in the top tier of programming languages worldwide. Look at job postings, look at GitHub activity, look at the number of huge enterprise systems still relying on it and building new things with it.
So reports of its demise have been greatly exaggerated.
Very much so. As we just mentioned, the language is evolving. New versions come out regularly, adding modern features, improving performance. And with frameworks like Spring Boot, it's incredibly well suited for the kind of applications everyone is building today. REST APIs, cloud microservices, containerized apps using Docker and Kubernetes. It fits right into that modern cloud-native world.
That's really clear. So if someone listening is thinking about learning a language or maybe adding one to their skill set, who should really be considering Java?
Well, if you're interested in Android development, Java is still essential knowledge. Even with Kotlin's rise, you need Java to understand existing apps and the platform's foundations.
Okay, Android devs. Who else?
Anyone aiming for a career in back-end systems, definitely. Especially in sectors like finance, insurance, large enterprises, e-commerce, Java is dominant there, building those robust, scalable, server-side applications.
So if building that core infrastructure is your interest, Java's a prime candidate.
For sure. Also, it's a fantastic language for really learning object-oriented programming principles properly.
Yeah.
It forces you to think in that structured way.
A good foundation, maybe.
A very strong foundation. And actually, even if you think you might want to eventually use other languages that run on the JVM, like Kotlin or Scala, starting with Java gives you a really solid understanding of the JVM itself, how it works underneath.
So it can be a gateway to that whole ecosystem.
Exactly. It provides a really solid base.
Okay, so wrapping this up, Java. Started with an idea for smart gadgets, but it grew into this foundational pillar of the digital world. From the tiny chip in a credit card to massive cloud systems, it's just quietly powering so much stuff.
It really is. It might not always grab the headlines like some newer languages, but its reliability, that huge ecosystem, the fact it keeps evolving. It's like that dependable steel bridge holding up the digital city.
Like workhorse.
The ultimate workhorse, maybe. It just keeps delivering.
Well, if you found this deep dive into Java useful, maybe share it with someone else who's curious about the tech that makes our world tick.
Yeah. Spread the knowledge.
Next time on the deep dive. Maybe we'll look at the speed of Go, or the sheer power of C++ Ms, or perhaps tackle that myth. Is there really such a thing as a perfect programming language?
Ooh, interesting options.
Oh.
We hope you'll join us for whichever one it is.
Ethically. Until then, may your syntax be clean, your class is tight, and your JVM runs smooth. Thanks for exploring Java with us today.